Today we are going to talk about using trigonometric ratios to find the length of a side of a right triangle when you know the length of one of the other sides and the measure of one of the angles. So first we need to review a little bit of what we learned in the last video about what the three main trigonometric ratios are. So remember that these ratios are just fractions that are made from the sides of right triangles. So when you have a right triangle, you can label the three sides as the hypotenuse, which is always the side across from the right angle. So look for the right angle, and it always points to the hypotenuse, which is the longest side. And then there will be one of the other angles that you're focusing on. In this case, that angle will actually have a number in it. It will say 23 degrees or 78 degrees. So you will know how big that angle is. You'll be focusing on that angle, and you will label the two legs as the leg opposite that angle, which means across from, opposite, so as far away from you as you can get from that labeled angle, and the leg adjacent, which means right next to that labeled angle. And based on those labels, we have three different ratios which we talk about. So the first one is sine, which is defined as the opposite side divided by the hypotenuse. So the sine of the angle is opposite over hypotenuse. The second one is cosine, which is the adjacent side divided by the hypotenuse. Cosine of the angle equals adjacent over hypotenuse. And the last one is tangent, which is the opposite side divided by the adjacent side. Tangent of the angle is opposite over adjacent. And we talked about there's an easy way to remember this, and that is SOHCAHTOA. So stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. What do you do when you stubba your toa? You go soka your toa. SOHCAHTOA. This is really important to remember. So first letter tells you sine, cosine, or tangent. Middle letter tells you which side goes on top of the fraction. Last letter tells you which side goes on the bottom of the fraction. SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Make a chant. Chant it to yourself before you go to sleep. Get it in your head. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So today we're going to be looking at how to find a missing side. So the first thing you want to do is you want to figure out which of the two sides the problem involves. So one of them will have a number on it. You will know how long one of the three sides is, and the other one will have an X or a Y or a Q or whatever. It'll have a variable. So it will be the one you're trying to figure out how long it is. And you'll figure out, well, which two do I have? Do I have opposite and hypotenuse? Do I have adjacent and hypotenuse? Or do I have opposite and adjacent? And you'll want to label those two on the diagram. And then you're going to want to use SOHCAHTOA to decide whether to use sine, cosine, or tangent. So if the two sides you know are opposite and hypotenuse, you would use sine. If the two sides involved are adjacent and hypotenuse, you'd use cosine. If the two sides are opposite and adjacent, you'd use tangent. The next thing you're going to do is you're going to set up an equation. So the equation would use the definitions of sine, cosine, and tangent. So you would write something like sine of 23 degrees equals x over 5.7, or cosine of 84.2 degrees equals 10 over x. So you'll plug in the angle that you know, you'll plug in the side that you want to find out, and the side that you know, and you put them in the right places in the equation. And the last thing you'll do is you will solve that equation for the missing side length. Before we start the examples, you need to make sure that your calculator is in degree mode. So a lot of calculators have a button that says mode, and if you push the button, they will have options that say something like DEG, RAD, GRAD, and you want to make sure that DEG is highlighted. So if you see RAD highlighted, you want to change it to DEG. And you may also see a little DEG up here on the top of the screen. That tells you you're in degree mode. If you have a calculator that doesn't have a mode button, it may have a button that says DRG on it, and you will want to push the DRG button until you see a DEG on the top of the screen. So once you have highlighted degree, you hit second, quit, and the second mode will get you to quit, and that will get you out of there. On a graphing calculator, it's very similar. Hit the mode button, and the third or fourth line down will say radian degree, and you want to make sure degree is highlighted. So go over till degree is highlighted, hit enter, and then you can quit. If you don't do that, you will get the wrong answers on this, because radians are a different way of measuring angles. And so you've got to tell your calculator, or these angles I'm putting in are in degrees. Okay, let me make this a little smaller. So this. So these questions ask me to write an equation involving sine, cosine, or tangent that can be used to find the missing length, and then solve the equation, and to round my answers to the nearest tenth. So the first thing I want to do is label which sides of the triangle I have. So I always start by looking for the hypotenuse. So here is my right angle right here, and across from that is the hypotenuse. So on this problem, 16 is the hypotenuse. And then I look at which angle I'm focusing on. So I'm focusing on this angle over here. So opposite and adjacent are based on that angle. The x is across from that angle, which means x is opposite. The unlabeled side is right next to it. The unlabeled side would be adjacent. So the sides involved in this problem are hypotenuse and opposite. The next thing I want to do is think about SOHCAHTOA. And I want to think about sine, cosine, or tangent. Which one involves opposite and hypotenuse? Well, sine. Sine involves opposite and hypotenuse. So, SOH. Sine equals opposite over hypotenuse. This is a SO problem. You don't have to write so, but that's going to help me remember. Now I'm going to write the equation. The sine of the angle. So here, this is the first time we've actually known what the angle is. So I write sine of 29 degrees equals, often people say, well, how do I know which one goes on top? Well, you look at the definition. Sine is opposite divided by hypotenuse. Opposite always goes on top. So which side is opposite? X is opposite. And hypotenuse always goes on the bottom. So hypotenuse is 16. And we need to solve this equation to get x by itself. So to get x by itself, we would go ahead and we would multiply both sides by 16. So that tells me that x is 16 times the sine of 29 degrees. That is what I'm going to type into the calculator. 16 sine 29. So that side length is about 7.8 units long. And it's good that that's shorter than the hypotenuse. It should be shorter than the hypotenuse. That looks about right, looks reasonable. So let's try another problem. So on this problem, I've got the right angle right here. The side across from that is the one that's not labeled. So the hypotenuse is not one of the sides I'm dealing with here. So the ones that are involved in the problem must be opposite and adjacent. So this is the angle I'm looking at, the 64 degrees. So the one across from it, furthest away from that, is opposite. That's the x. And the one right next to it, that's not the hypotenuse, is adjacent. So I think SOHCAHTOA. Which one has opposite and adjacent? Well, so that's opposite and hypotenuse. Ka, that's adjacent and hypotenuse. Toa, oh, toa, that's opposite and adjacent. So this is tangent. Tangent equals opposite over adjacent. That's what TOA stands for. So I go ahead and I write my equation. The tangent of the angle, 64 degrees, equals, opposite always goes on top. So in this problem, the opposite is x. And the adjacent always goes on bottom. In this case, the adjacent is 14. I want to get x by itself, so I'm going to multiply both sides by 14. So that tells me that x is equal to 14 times the tangent of 64 degrees. Which is about 28.7. That looks right. That side looks like it's longer than the 14, so that seems like a reasonable answer. So next problem, here's the angle I'm focusing on. Here's the right angle. Across from the right angle is the hypotenuse. So 18 is the hypotenuse. And the x is right next to that angle. So the x must be adjacent. adjacent and hypotenuse, cosine equals adjacent over hypotenuse. This is a problem. And again, that's just a way to help remember what you're doing. Ka isn't a math term, it's just a mnemonic device. It's a way to remember how to do the problem. So I have cosine of the angle, which is 58 degrees, equals A is adjacent. Adjacent always goes on top. So adjacent is X, and hypotenuse always goes on bottom. Hypotenuse is 18. So I'm going to multiply both sides by 18. So X is equal to 18 cosine 58 degrees. About 9.5. That seems reasonable. The hypotenuse has to be the longest side. This is shorter than that. So those questions went pretty quickly. Now notice on all three of these equations, the x ended up being the top side. Here x was opposite, and opposite is on top in sine. Here x was opposite, and opposite is on top in tangent. Here x is adjacent, and adjacent is on top in cosine. But what if I have a triangle where the x is the hypotenuse, or the x is adjacent in a tangent problem? The equation is a little different to solve if the x is on bottom. So let's look at a couple of those problems. Starts the same way. You always set all of these problems up the same way. The only difference is going to be in how we solve the equation. Okay, so here's my angle I'm looking at. Across from the right angle is x, that's the hypotenuse. And the 12 is right next to the angle I'm focused on. So the 12 is adjacent. So which one of the three involves adjacent and hypotenuse? Well, cosine does. Cosine is adjacent over hypotenuse. So this is a problem again. So I write the equation just like I did in the previous problems. The cosine of 65 degrees equals, well, adjacent always goes on top. Adjacent is 12 over hypotenuse. Hypotenuse always goes on bottom. Hypotenuse is x. So this is where things go a little bit differently than they did in the previous problems. This time, before we can get x by itself, we first have to get x out of the bottom of the fraction. So the first step is to multiply both sides by x. You can't solve for x while it's in the bottom of a fraction. So first you got to get it out of the bottom of the fraction. So that gives us x times the cosine of 65 degrees equals 12. And then you can get x by itself. You're multiplying right here. So to get x by itself, you divide by cosine of 65 degrees. So that tells me that x equals 12 divided by cosine of 65 degrees. So if you look at the problems up above, you ended up doing something times the sine of something, or something times the tangent of something, or something times the cosine of something. When x is on the bottom of the fraction, you're going to do something divided by the cosine of something, or something divided by the sine of something, or something divided by the tangent of something. So here I'm going to have 12 divided by cosine of 65. And that gives me 28.4. And that's good. I know the hypotenuse is supposed to be the longest side, so I'm glad that that's bigger than 12. So these are two-step algebra problems instead of one-step algebra problems. First, multiply both sides by x, and then divide to get your answer. So let's try another one of these. So here's the angle I'm focused on. Across from the right angle is the hypotenuse. That side isn't labeled, so hypotenuse isn't involved here. 71 degrees across from that, opposite, is 16. And the x is right next to that, but isn't the hypotenuse, so the x is adjacent. So opposite and adjacent, that would be TOA, tangent. Tangent is opposite over adjacent. So I'm going to write the equation. Tangent of 71 degrees equals opposite 16 over adjacent x. So always just look and say, okay, opposite goes on top. Which one's opposite? Adjacent goes on bottom. Which one's adjacent? All right, I've got to get x out of the bottom. So multiply both sides by x. That gives you the x times the tangent of 71 degrees equals 16. And then you need to get x by itself, so divide both sides by tangent of 71 degrees. So x is equal to 16 divided by tangent of 71 degrees. Which is about 5.5. All right, this one, here's your right angle. So across from the right angle is the hypotenuse. That's the x in this problem. And the angle we're focused on is the 26 degrees. The 12 is across from 26 degrees, so that's opposite. Opposite divided by hypotenuse would be sine. So, opposite over hypotenuse. Sine is opposite over hypotenuse. Sine of 26 degrees equals, opposite always goes on top for sine, so 12 is opposite, divided by hypotenuse always goes on the bottom for sine, so hypotenuse is x. Have to get x out of the bottom of the fraction, so multiply both sides by x. That gives you that x times the sine of 26 degrees equals 12. Divide both sides by the sine of 26 degrees. So x is 12 over the sine of 26 degrees, which is about 27.4. Okay, I'm going to stop this video here. I will do the other 6 examples on a second video. If you want to watch those, you are more than welcome to. The second set of 6 problems, the problems with x on the top and x on the bottom are all mixed together. And the same thing will be true on your homework. So if you're still a little confused about, well, how do I know whether x is on top or x is on bottom, watch the second video. There are also some really good homework help links that I have put on the assignment page down below the homework. So take a look at those if you're having trouble understanding this.